Imagine your phone is working perfectly fine, but every text you send comes back as complete nonsense. Now imagine that phone is 15 billion miles away, and every time you try to fix it, you have to wait 2 days just to find out if your last guess even helped. That's the exact problem NASA faced with Voyager 1. There was no reboot, no repair truck, no live troubleshooting, just patience, and a 2-day delay on every single guess, for months, with no guarantee the next guess would work either. Here's what actually happened, and how a small team of engineers solved a problem on a machine they could never touch. Voyager 1 launched in September 1977 on top of a Titan 3E Centaur rocket on a mission that was only ever supposed to last 4 years. Its job was simple on paper: fly past Jupiter and Saturn, take pictures, gather data, and send it all home. It finished that mission in November 1980. Then it just kept going. Today, Voyager 1 is the farthest human-made object in existence. It crossed into interstellar space back in 2012, meaning it left the bubble of particles and magnetic fields generated by our sun and entered the space between stars. No other spacecraft has ever operated this far from Earth. There is nothing to compare it to, and nothing behind it to learn from if something goes wrong. For most of its life, Voyager 1 has done exactly what it was built to do. It sends data home. It receives commands. It keeps flying in a straight, predictable line at about 38,000 miles per hour. Then, at one point, something changed. A system on board called the Attitude Articulation and Control System, or AACS for short, started sending back telemetry that didn't line up with reality. Not silence, not static, which would almost have been easier to diagnose. Instead, it was data that looked like it had been generated at random, numbers that didn't correspond to anything the spacecraft should have been doing. Here's the part that made this especially strange. Voyager 1 was still flying correctly the entire time. Its antenna was still pointed exactly at Earth. It was still receiving commands from mission control and carrying them out properly. It just couldn't accurately report on its own status. It was like the spacecraft had lost the ability to describe what state it was in, even though the actual state was fine. This is where the real difficulty of working with Voyager kicks in, and it's a difficulty most people never think about when they picture space exploration. A round-trip message to Voyager 1 and back takes roughly 2 days total. That's not because anyone is being slow, it's simple physics. Radio signals travel at the speed of light, but light itself takes over 20 hours just to reach Voyager one way. So the process looks like this. Engineers send a command, then wait about a day for it to arrive, then wait another day for Voyager's response to come back. There is no live back and forth. No watching a console update in real time the way you'd troubleshoot a computer sitting on your desk. Every single test the team ran meant committing to a 2-day wait just to see whether that specific guess was right. So the engineers at NASA's Jet Propulsion Laboratory had to work methodically. They ruled out the simplest explanations first, because chasing complicated theories before eliminating basic ones would have wasted cycles they couldn't afford. They checked whether the antenna itself had a problem. It didn't. Voyager was still pointed correctly and still receiving instructions. They checked whether the spacecraft had entered what's called safe mode, a defensive state where it shuts down non-essential systems to protect itself. It hadn't. Piece by piece, they eliminated possibility after possibility, always on that same 2-day cycle, always waiting to see if the data that came back matched their theory. Months passed this way. Not because anyone was working slowly, but because that's simply how long it takes to debug something 15 billion miles from your desk. Eventually, the investigation led the team to something specific: a single corrupted chip inside Voyager's onboard computer memory. That one chip played a role in how the AACS packaged its telemetry data before transmitting it back to Earth. Once that chip stopped functioning correctly, the information coming out the other end was essentially garbled. The AACS system itself was working fine. It just couldn't correctly describe what it was doing to anyone listening. Fixing this wasn't like fixing a normal piece of hardware. There's no way to send a technician 15 billion miles to swap out a faulty part. Instead, the fix had to happen entirely through software, sent as a set of commands across that same 2-day communication cycle. Engineers rerouted the affected code to a different part of Voyager's memory, one that was still functioning properly. Once that rerouting was confirmed, the telemetry started making sense again. Months of uncertainty ended with a clean, verifiable answer. Not a mystery that stayed unsolved, not a phenomenon nobody could explain, but a specific failure, found and worked around, using nothing but patience and careful process from a distance no human will likely ever cross. That particular mystery is resolved. But Voyager 1's story of unexpected problems hasn't stopped, and in some ways, 2026 has been one of its more difficult years yet. Voyager 1 runs on a radioisotope thermoelectric generator, a power source that converts heat from decaying plutonium into electricity. That power output has been declining steadily since launch by roughly 4 watts every single year. There's no way to recharge it, and there's no replacement coming. To keep the spacecraft alive, NASA has been shutting down instruments and systems one at a time. In a carefully planned order, the mission team worked out years in advance. In April 2026, they powered down an instrument called the Low Energy Charged Particles Experiment, a system that had been running almost without interruption since 1977, nearly 49 years of continuous operation. Then, during a routine maneuver in late February, Voyager 1's power levels dropped unexpectedly, closer than engineers wanted to, a threshold that would have triggered an automatic shutdown of onboard systems, a process that would have required a long and risky recovery effort to undo. Now the team is testing a larger fix, nicknamed the Big Bang, first on Voyager 2, which has a bit more power to spare and sits closer to Earth. If that test goes well over the coming months, the same fix will be attempted on Voyager 1. If it works, there's even a chance some of the instruments that have already been shut down could be turned back on. It's the same pattern as before. Aging hardware, operating in an environment nobody designed it to survive this long in, with no easy fixes and no room for mistakes. Just careful, patient engineering, 1 2-day cycle at a time. Voyager 1 was never designed to last this long. Every single anomaly it produces now is uncharted territory, because there is no other spacecraft this far from Earth to compare it to, and no precedent for what a 49-year-old machine should look like out here. Each mystery NASA works through, whether it's a corrupted memory chip or an unexpected power drop, teaches engineers something new about keeping hardware alive decades past its expected lifespan, operating in temperatures near absolute zero, light hours away from anyone who could ever physically repair it. So the unexpected thing Voyager did wasn't a signal from something unknown, and it wasn't evidence of anything beyond straightforward hardware failure. It was a solvable problem, but only barely, and only because a team of engineers were willing to wait 2 days at a time for months, testing one careful hypothesis after another, until they found the answer. Someday, likely sometime in the early 2030s, Voyager 1 will run out of power completely. It will go quiet, but it will keep moving outward, carrying the golden record with it, for longer than any of us will be around to track it. If you want to see the next unresolved space mystery broken down the same way, this channel is where I do it. Just the evidence, no ancient aliens.